Hey guys, welcome to lesson 3.1.1. We are going to continue to build off of some of the stuff that we learned this past chapter, and we're going to be talking about how to figure out if two expressions are equivalent. Those two expressions will typically show up in different formats, and we have to do some work to figure out if they actually are belonging to the same function. All right, and we're going to do that by using tables, graphs, and then also algebra and the equations themselves. So for our first example here, I have an expression or a function in standard form, and then I have one in factored form. So the first method that we're going to talk about to determine whether they are equivalent is going to be using these tables. So the way that you want to do that is you want to pull up your calculator, and typically you'd be at this screen right over here. You'll go to y equals and graph the first function. Okay, I have that typed out for us already. So I'll go ahead and hit graph. And what we want to do is go ahead and go to the table. So once your graph shows up, you're going to press second and then graph. That's how you get to your table. And it should do that now. And we'll see that we have some points here that we can use. So I haven't required you to do any specific points here, so let's just choose some that seem good. All right. I'm going to have to bring up my calculator like a million times here since it's not going to stay. But we have negative 3, 0, negative 2, 0, negative 1, 2, 0, 6, 1, 12, 2, 20, and 3, 30, 4, 42. Oops. 3, 30, 4, 42. Okay, now that we've finished filling out our first table, we're going to go back to our calculator and graph the second function. So we have x plus 2 times x plus 3. And we're going to look at that table. We can just go straight to the table. Press second and then graph. Go straight to the table. And we can figure out whether this table is the same as our original one or if it's different. So let's just take a look at the comparison here. Oop. Doesn't want to pop up. Okay. So here we are. If we look at those next to each other, we have negative 3, 0, negative 2, 0, which matches our first 2 points here. Negative 1, 2, 0, 6, 1, 12, 2, 20, 3, 30, 4, 42. So from what we see here, the tables are pretty much the same. And if the tables are the same, we can go ahead and jot down that second table here. That must mean that the two functions are equivalent. Okay, and it makes sense, right? If they have the same tables, that means they have the same points. And if two equations have the same points, then they've got to be equivalent. They have to be the same, pretty much. Okay, so since these two tables are the same, tables are the same, so that means they're equivalent. All right, so next we're going to talk about how to check this out on the graph. So we just talked about how to do it on the table. For the graph, you can go ahead and go to back to your calculator and hit y equals, and we're going to graph both of our functions. So the first one was x squared plus 5x plus 6, so let's add that in here. It doesn't matter which one you write first and which one you write second, as long as they're both there. And we'll hit graph. All right, here's our first graph. And here is the second one. It's going to show up. Okay. So notice how that red graph graphed right on top of that blue one, right? We can tell that both of these graphs overlap perfectly. So they must be the same graph. Okay, we have perfect overlap. So if it's the same graph, that means they are equivalent. All right. Okay, so that is how you would figure out whether two functions are equivalent using the graph, right? You just check to see if they fall on top of each other. All right, the last method we have is to do it algebraically. Now, there are two ways we can do it algebraically, and I am going to show you both of them. The first method, we'll call that method 1, okay, involves factoring. Now, if we look back up here and remember that I said at the beginning of this lesson that this is an equation that's in standard form and this is one in factored form. So one cool way to figure out if they're equivalent is just to factor this first one and see if we get the same thing as what the second equation says. So we would factor f of x is that first equation, factor f of x to see if you get g of x. Okay, f of x is the first equation, g of x is the second one. All right, now recall that the equation was x squared plus 5x plus 6. Okay, so now we're just going to go ahead and box and diamond this, and that's something that you guys should be pretty comfortable with considering we've been doing it for quite a while now. So, as usual, we'll draw our box, and we'll draw our diamond. Okay, and the top left corner of the box, we put our first term. The bottom right corner, we put our third term. And of course, when we are filling out the diamond, the top is going to be the first term times the third term. And the bottom is going to be the middle term. Okay, again, this is stuff that we've learned previously. If you want more explanation on factoring, please go refer to my original video about factoring. Okay, and now we get to play the game, right? We have to ask ourselves, okay, what times what equals 6 and what plus what equals 5. All right, so hopefully you would eventually realize that 3 and 2 would fit the bill. Let's rewrite that. 3x and 2x, because 3 times 2 equals 6, so we're good on there, and 3 plus 2 equals 5, so we're good there. Fill out the rest of the box. Oops. All right, so now on the outside we know that it's going to be x and x to make x squared. 3 goes here and 2 goes here. Our final factored form ends up being x plus 2 times x plus 3. Okay, and sure enough, if we look back up at g of x, that is the exact same equation, and that tells us that they are equivalent. Yay. All right, so that's the first method. We can factor the first equation to see if we can get to the second equation. Second method is to go backwards. Now for this one, we can look at the second equation and multiply this out. We can distribute it all out and see if we end up with the first equation. Okay, so method 2 is to multiply out g of x to see if you get f of x. All right, and this is actually the method that MyOpenMath is going to have you do on today's practice problems. So recall that our original that we're working with then is this. Right, it was x plus 2 times x plus 3. Oh, oops. Let's fix this. I meant to write g of x equals x plus 2 times x plus 3. All right, so let's multiply this out and see if we end up with the same thing as f of x. So we'll still use a box, and if you guys remember, when I first taught you to factor, I taught you how to multiply binomials. So if you don't remember this, go ahead and check that factoring video out. It'll be in there. But we're going to put x plus 2 on one side and x plus 3 on the other side. Does not matter which side you put which one. Okay, and then we just multiply base by height. So x times x is x squared. 3 times x is 3x. 2 times x is 2x, and 2 times 3 is 6. All right, and now all we got to do is add everything together in this box and see if our simplified form ends up with f of x. Right, so in our box we have an x squared. These two, I circled them because they're like terms and we can combine them. 3 plus 2 gives us a total of 5 x's, and then we have a 6. Okay, so we ended up with this, and sure enough, that's exactly the same as f of x. So that's good, and that means they are equivalent. Okay, so those are the ways you can do it algebraically. We have one more example here. And this time, I would really hope that you would recognize the formats here. I have another equation in, well, I should say expression, in standard form. And I have one in graphing form. I hope you remember that that's graphing form. Let's go ahead and call this first one f of x, and let's call the second one g of x, since that's the notation we're used to now. And remember, this is graphing form. And this one is standard form. All right, that's kind of ugly. Okay, so for this problem, again, we just have to go ahead and put those in our table, or in our calculator, to graph them and find the table. So I'm going to go ahead and pause the video at this time so I can type this all in, and then I'll continue it so that I don't waste that time here on our video. Alright, so I've typed in my equations, and I'm going to go ahead and go to the table. So second and graph gets me the table, and this is what I'm going to write. Okay, and I can already tell by looking at the table that they are exactly the same, right? This is the first table for the first equation, and this is the table for the second equation. Every single point matches for every single x value. So that's what I'm going to put down for my points on my table, and then we'll go from there. I'm going to go ahead and pause the video again so that you guys don't have to watch me do that. Alrighty, so I have gone ahead and wrote down my two tables based on what I saw here, and I use the same colors. And so now for graph, we can go ahead and press the graph button, and notice that the first equation is right over here like that, and the second equation ends up right on top of it. Okay, so if I were to just draw a little sketch, now they both ended up right on top of each other, so it's going to be like exactly the same graph. It's going to end up right over here somewhere. I'm just going to sketch it out. Okay, and they both ended up right there. Excuse my ugly graphs. Okay, and so we can tell from here that they're equivalent because the tables are the same. And we can tell here, because the graphs are the same, that they're equivalent once again. Okay, so now for the last way to show equivalence, and this is the algebra way. Now, again, we can still go into methods with this one too. The one I'm going to show you is the one that you guys are probably more familiar with. Remember that you're welcome to go between these two in any direction that you want. But what we're going to do is take this standard form equation, and we're going to turn it into graphing form. And the reason I've chosen that method is because we're very used to turning things into graphing form, right? We do that by completing the square. Okay, so this is where we just take our box, set her up so we put the first term there, split our middle term in half, so 3x, 3x, and then you fill out the outside. Right, x times x is x squared. We get a 3 here and here, and that tells us that 3 times 3, we get a 9 in this box. All right, we're almost done. We get x plus 3 squared, and then we have a 9 here, but we need to get a 5. Okay, so to get from 9 to 5, we would need to subtract 4. Now, we can tell that we did end up with exactly what f of x was, right? So we can tell that they're equivalent because we got the same equation again.